So good morning. Thank you for coming to this session about Javaslang and Groovy. Today I'm going to talk about this Java library, Javaslang, and I'm going to show you why it's a very good fit for Groovy. Some of the things that this library provides us, we already have them in Groovy, but there are other things that are new for us, so new data structures. So because Javaslang, it's a way to have a functional approach into the Java platform, right? Before I start, let me introduce myself. I'm Iván López at Ilomar on Twitter. I've been using Groovy and Rails for the last 7 years. I work at OCI. You know OCI if you are here. Now I'm a member of the Rails team at OCI. I'm also the coordinator of the Madrid Groovy user group, our local Groovy group here in Madrid. You have in our website, madridgroovy.com, all the information. We have talks once a month. We always record our talks, and if you are from here, from Madrid or nearby, you are welcome to join us. You know, I'm one of the guys behind this conference, and I'm also a regular speaker at different conferences around the world. So, this is basically my last slide. So we can go now? No, please, wait. So I'm going to explain everything using live coding, using Spock. This is not going to be a Spock talk. So if you know Spock, perfect. If you don't know Spock, first thing, you should learn Spock. And the second thing, don't worry. It will be very simple Spock. And I'm going to use Spock because, well, it's awesome. But also because with Spock, I can run the code, and I can write some tests, and I will make sure that everything works as expected, and you will understand everything that I explain. So as I said, that's all. This project, I will push the code to GitHub after the talk, so don't worry about the code. Just attend to the talk, and then you will be able to play with the code. So I have a Groovy project. Let me start presentation mode. And this is my bindle Gradle. Pretty simple. I'm using the latest Groovy, 2.4.10. I need to add the Javaslang dependency. And then, of course, Spock for the test. I'm using the latest RC3. And that's all that you need, OK? So let's start with option. So if you are using, if you know Java 8, you know that in Java 8 we have optional. And the main goal of option in Javaslang, or with optional, it's to eliminate the null checks, right? So option, it's a container and can contain a value, or maybe no, if it's empty. And we can take advantages of optional, and I'm going to show you how. It's pretty much similar to Java 8 optional, but option, it's better. The API, it's richer, it's iterable, and also it's serializable, which optional it's not. So this is the first example. This is Java 8 optional. And if you are using this, let me turn hint off. If you are using Java 8, you know that you can do that, right? If a value can be null, this will throw a null pointer exception. So I'm going to run the test, and it's going to pass because this code will throw an exception, right? So it's green. If you want to make sure that the code doesn't throw an exception, you need to use of nullable, OK? So with Javaslang, you don't have the problem. You use option of and a value, whatever value you want. You can see here that I'm using null again. But now, this won't throw an exception, OK? And as I said, inside this option, it's something like a container. You can have two different values. If there is something there, you will have a sum, because it's something. And if it's empty, you will have a none. So in this case, it's null, so it's empty. This will be instance of none, because there is no value there. And the to-string representation of this none, this empty value, it's just this string. I can put here something like Greach. And now, let me delete this. So now, option, it's an instance of sum, right? And option.toString will be something like sum and the value, Greach. Let's run the test. Yep, green. Okay? Let's move to the next one. Imagine that you are using optional, Java 8 optional all over your code, and you want to introduce this new library and switch to option. You can use it. You have this method. So we here are creating a Java 8 optional, and we have this method of option of optional. So we are converting from Java 8 optional to Javaslang option, right? And as I have a value here, as in the previous example, this will be an instance of sum, because there is a value there. And now we can do a new things. So imagine that you have something like this user service, which is just a very ugly and pretty bad implementation. So if I pass some name, I'm going to return, instead of just returning a user, I'm going to return, user is just a Groovy class with name and age. So if I receive some name, I'm going to return some user, Iván, and 37. And if not, I just return a none, which is an empty option, right? This is my pretty simple implementation. So what I can do now is just I call the service, and then I execute this map. And this map will only be executed if this option it's a sum. So if is there a value there? You don't need to worry about checking the code with if user service is not null, then I do this, and if not, I do anything else. So I'm going to run this, right? So with the get, you actually get the value from the option, and here what I'm doing basically is I get the username or the name, and I convert to uppercase, right? So this is why this is Iván in uppercase. And as the same as before, if we don't pass a value here, now this will be an instance of none, and this map won't be executed. So with the same code, you have both options, or both branches. You don't need to worry about that. And another thing that we can do is to define something like a default value, right? So we have here let me do this. You have here this map, but if there is no value, so if this is a none, I want to return anything else. In this case is with this or else, I'm going to return an option of John, right? So as this is empty, when I execute the get, I will return John. So imagine that you put all of this inside a method and you call it, right? In this case, when you develop that method, you are deciding the default value. A better approach is to do something like this. You just return the option, and you let the client, the caller of your API, to decide the default value. So here, I'm saying, OK, get me the value, and if there is nothing else, I can, please give me John. If I put here, again, Iván, and I run this test, it's going to fail, right? Because you can see here, this is a sum of the value. I execute the get or else, in this case, only the get, because there is a value there. So Iván, it's converted, it's mapped to uppercase, and well, it's not John, test red. OK? Any questions so far? OK, we'll wait until the end. Let's move to the next example. Try. So this is new. So in Java, in Javaslang, a try is a container for a computation that can throw an exception, right? So instead of grabbing our code with a try-catch block, we can use this try data structure. And in the previous example, we saw that an option can be a sum on a none. Here, with a try, we have two different values, or two different types. If there is an if there is an exception, the try will be a failure, and if not, it will be a success. So you can see this something like, instead of dealing with exception as something that can be thrown, you can deal with exception as a data, right? Let me show you the first example. We have this method. Let me delete this. We have this method. We are trying to divide x between y. And as you know, if I do this, so in this case, 40 divided by 10 is 4. Let's run it. Okay? But what happens if I do this? Yeah, boom. Arithmetic exception, right? Division by 0. This is grown. So sometimes, to avoid this, you do something like this. Try this ugly code. Try catch. Oh, I don't know how to write today. Arithmetic exception. And here you do stuff. Right? So you don't have the exception. I don't know. I need, yeah, this one. Better now. No, I broke everything. Well, you know. Let me delete this and continue. So you can see the problem, right? You need to write this ugly code that I don't even be able to write now. And it's pretty simple, only 2 lines, and I'm not able to do it now. So we have a better approach, which is this code that I deleted. Instead of just dealing with the exception or throwing the exception, you put here inside of a tray the computation that can throw this exception. And we retry, instead of returning the big decimal, we return a try of, in this case, big decimal. So now, if we go back here to the test, we are going to divide it again by 0. But now I'm going to run the test. It's green, and I'm not, as you can see, I'm not catching the exception because the exception has been thrown, but Javaslang will catch the exception for us, and we can treat the exception as a data. So here, the first thing is it's an instance of failure. So this is a new method. Its failure is true, its success is false, and here we have this cause is a throwable, so it's the exception that has been thrown. And we can do here print line. If I run this again, we can see the actual exception, right? So we have the same, but with that ugly code. And we have even a new option here. So we have methods pretty much the same as with the option. So we can say, OK, if I don't know how to divide this, let's return, for example, a -1. OK? If you want to do that. So now if I do this, let me delete all of this code. Here, the result will be an instance of a success. No, not this one. Success, this one, right? And I can do result.get, and it will be big decimal value of 5. OK? Perfect. What else we can also map the values, so we can chain one call after the other without dealing or explicitly in the code with this try. If there is some error, please go here. If not, I put the code inside the try catch, the try block. So here it's basically as with option. I want to do this, and then if it is a success, I'm going to execute the map. So I'm going to multiply the number by 2. If not, I'm decided that I'm returning 0. So in this case, this will throw the exception or the failure, and this will be executed. So this test is green now. And if I put here some value, the test is going to fail, and it will be because, so 15 divided by 10 is 5. 50 divided by 10 is 5. 5 times 2, it's 10. So here, success of 5, success of 10, get the 10. Well, it's not 0. OK? And the last thing I want to show you about try, it's that we can also recover from a failure. So let me run this code first. Here, imagine that we are doing something and we want, for example, store the data, the value on a database, right? So we map the value to execute this method just to save, for example, save something on a database. And as you can see here, we have this output, number 5 saved correctly. But we can also recover or try anything if there is an error here. So if I do this and create the exception, now what is going to happen is that this map won't be executed because there was an error, but the recover method will be executed. And you can see here, there was an error, and we have, again, the throwable that has been thrown. OK? Next one. functional interfaces. Yeah, if you are familiar with Java 8, you know that they introduce a lot of functional interfaces, also functions. But basically, in Java, we have two function interfaces, right? One is just function that receives a value and return another value. And the other one is by function that receives two values or two types and return a new one. And the thing is that that's all. We don't have anything else on Java 8. But what happens if tomorrow, well, not tomorrow, maybe for Java 11, they decide to introduce a new functional interface in this kind? Probably, if they need 3 parameters, they will call it try function, quad function, or I don't know, quint function. I don't know that much English. So the API is not really consistent, right? So this is Java 8 function, right? We are receiving an integer. We return an integer. And here, instead of using a lambda 8, sorry, yeah, Java 8 lambda, we are using a closure. And this function has this method apply. So I apply this function to the number 5. So 5 times 5, it's 25. Perfect. And the same with by function. I receive 2 parameters, in this case, name 1 and name 2. And I add those numbers. So 5 plus 7, 12. Perfect. And another thing that we can do with Java 8 is composing functions. So imagine that you have these isolated functions. We have this square that receives a number and calculate the square root, and plus 2. We can write something like this, a square, and then plus 2, apply 10. So what this code is going to do is, okay, I pick the first one, a square, I pass the value, 10, 10 times 10, it's 100, and then I apply the next one, plus 2, which is the number plus 2, so 100 plus 2, 102, right? But the thing is that we can do the same in Groovy, because we have closures from the very beginning. So this is new for Java 8. So they've been waiting 20 years to have this. We have this from 10, 12 years ago. And it's the same. We can create this square. We grab the code in a closure, square plus, and we have 2 different options to apply to execute this same thing, this same line. We can say like this, okay, I'm going to pick the 10, and then apply the square, and then apply the plus 2. Or I can do the other way, a square, and then plus 2, call 10, because this is a closure. You can do something like, you can do, I think this will work. Yeah, because it's a closure and you are just calling with the parameter. You don't need to execute explicitly the call method. But this code is a little bit ugly, so I suggest you use the call. And now let's see what we have in Javaslang. So we have the API is pretty consistent. So we have from function 1 to function 8. It's not try function, be function, whatever it's function, and the arity of this function. Now, from 1, I think from 0 to 8. And it's the same. Function 1, we use a closure. Function 2, we use a new closure with 2 parameters. And it's the same. Here I'm applying first the sum. So I sum 10 and 20. And then I calculate the square root. It's the square root? Well, whatever. 20 plus 10, 30. 30 times 30, 900. And I have here an example, for example, of function 4. If you need to create a function with 4 parameters, which are this one, you can do it. I pass 4 parameters, and then this is pretty simple. I only want to sum the size of these values. Here I put an integer. So 3, 2, and 3, it's 11. Pretty simple, right? But the thing about Javaslang functions is that the API is richer than Java 8 functional interfaces or function interface. So imagine that we have something like this. We have here a computation, again, the same one, square. And let me do something like this. Print Javaslang num and this. So if I run this test, what is going to happen is, obviously, I'm calling the method 4 times, so I have 4 prints, right? But the nice thing about functions is that a pure function, which these are or should be, for the same input, you always have the same output, right? This is not going to change, never. It shouldn't change. So the thing is that once you calculate the value, the same value for the first time, you don't need to calculate it over and over and over again for the same value. So Javaslang function interface have some methods, such as memoize, right, that we already have in Groovy. We are going to see it. So with memoize, basically we are caching the results. This method will create a new function, which is this square memoize. And now, for every input, he's going to cache the return value, and it's not going to execute the computation. Here it's pretty simple, but here imagine that you are executing something that it's very compute resource extensive. So if I run the test again, all the test pass, because this will be true in the 4 cases, but the computation has always been calculated the first time, right? And the thing is, as I said, this is the same example with Groovy, and in Groovy we have exactly the same. Memoize, let me do this the same again. So print line, Groovy num. Yeah, I need to put more than one. Right? It's the same, because it's creating this cache. But Groovy, it's more powerful, because we have more methods than, in this case, Javaslang. We have this memoize and with different implementations. So memoize at most. The thing is that this is creating a cache. If you call this function with a lot of different values, maybe you can have a memory exception, because it's taking memory, more memory. But we can, with Groovy, we can say, OK, catch me at most one value. So what is going to happen now, let me do this. If I pass this number, if I do this, right? Let's start with this. Groovy 10. For the second call, the value is already there and on the catch, so not printed. Then I execute with a different value, with 11. Then again, but now if I put here again 10, you will see the print again, right? Because I have defined a cache for only one value. So with these methods, you can define or control the cache. You are not going to allow to grow until your Java memory blows up. Okay? Anything else? Tuple. This tuple, it's a common concept in functional programming languages. And the thing about tuples is that they can hold different values, different types, right? In a type-safe manner, and this is important. Javaslang provides tuples from 0, which is no value, to 8. And the API, it's the same. So you are going to see this one. So as you have seen in this previous example, the Javaslang API is pretty consistent. Tuple of, function of, option of, it's always the same. And in this case, I'm going to return a tuple of 3, right? Just 3 random types. Name, I receive this, imagine I'm creating something like a user, I receive the name, the integer, and I'm going to create a tuple with the name in uppercase, the age -10, and then true, okay? So I forgot to mention that in Groovy, we already have tuples. We have tuple and tuple 2. But Groovy tuples are just like a list, right? It's not that powerful as we did with this Javaslang. So here I'm returning this tuple of 3 elements. And with this method, underscore 1, 2, and 3, right? This is the method. This is the Groovy way to access that. We can just retrieve all those values. So the first one, it was, remember, let me do this. So the first one is the name in uppercase. So Iván in uppercase. The second one is the age -10, so 27, I wish. And the third one, well, a true, okay? And here with tuples, we have a very rich API, so we can do a lot of things. For example, we have different methods, map1, map2, map3, to apply a function to only one of those parameters. So in this case, I'm using map1, which is the first parameter, remember, and a string. And basically, I'm converting to lowercase again and reverse. So here, I'm applying this function to this tuple, and I'm returning a new tuple. Because one of the things about Javaslang is that all their data structures are immutable. We are going to talk about immutability in the next examples. So the thing is that I'm not modifying that tuple, I'm creating a new one. That's why I need to get, again, the first element of that tuple. And I can, for example, apply a function to the whole tuple, right? So in this case, remember, it's a tuple 3, a string, integer, a boolean. So I have, for example, these 3 names, and I create this to a string, yeah, concatenating everything. But I can also do something like this. Let me check my notes because I don't want to fail. Function 3, a string, integer, boolean, concatenate info. And then here I can use again a Groovy closure. No, sorry. I can create a function 3 of, and here I'm using the Groovy closure, right? So name, basically it's the same as I have here, and copy and paste it. And here I can do something like this: user info dot apply. And you can see here that this method has a function 3 parameter. So I can do concatenate info, and the result will be, let's copy and paste again, this one. Okay, it's true. You can see in these orange colors that IntelliJ's not very happy about these things. So sometimes you need to just live with it, because I think it's not that simple to know what's everything inside all this API from a Groovy point of view. But this works and it compiles, but just IntelliJ, it's not aware of all those types. And one nice last thing I want to show you about tuples is that we have a lot of methods for free. So for example, we have comparators for free. We don't need to do anything else. So imagine that you have this, a tuple of 2, and this can be, for example, points in a two-space map. So x and y, I can define these points. So I can just compare the points. And point 1 is less than point 2 because 5 is less than 7. Point 3 is greater than point 2 because 11 is greater than 10. And point 3 and point 4, it's equal to point 4 because they are just the same. So we have a lot of methods, and the API, as I said, there are here, you can get the arity, the compare, you can map, transform, update. There are a lot of things that you can do with the tuples. And now let's talk about collections. The problem with Java collections is that they are mutable. And it's wrong, or it's bad, because it's pretty simple to have some bugs. If we don't think about side effects, especially when we are dealing with concurrency code. So Javaslang collections, as I said, are immutable. So we have, with immutability, we have safety for free. We don't need to worry about that, because every time we try to modify a collection, we are actually not modifying that collection. We are creating a new one, right? Under the hood, Javaslang will reuse most of the values. But this is, from our developers' point of view, it's totally transparent. You don't need to worry about that. They are just implementation details to basically have a performance collections. But for us, it's just a new collection, right? So another thing, remember this API consistency, list of, tuple of, anything of. And this list is not Java util list, okay? It's Javaslang list. So this is a Javaslang list, and we have this method, list.sum. If we create a Java util list, so Java list, we can say 1, 2, 3, 4, right? So this is a Java list from Groovy point of view. We can define it like this. And here we have the same method, sum, but this method comes from default Groovy methods. If you are using just plain Java, you don't have this method. If you want to do something like sum the elements of a Java list, you need to do something like this. You need to stream the values, that you need to map int. Here I need to put a lambda, so I'm writing a closure, just return the value, and then here I have the sum method, right? And this will be 10. So from Groovy point of view, we can do, as I said, java_list.sum. But from Java, this is a great improvement. You don't need to think or even remember this. You have a lot of methods. But as I said, even if we have this in Groovy, this Java util list is mutable. And I'm going to show you now the last example is about that. We have a lot of different methods, as I said. So for example, we have an empty list. We can create a list of, or list.empty is the same, is empty. And imagine if we want to get, what happens if I want to get the last value? I can say, okay, tail, and I don't know, 0. It doesn't matter, it's going to fail, because this is empty, right? So this under the hood is using optional to grab everything, and that's why we have this tail option. If we are not sure about the values, we should use option, because instead of dealing with this unsupported operation exception with null, we just get an option, and we can get this get or else method. So this is an empty list, so the default list would be this one. And with this method to Java list, we are converting the Javaslang list to the Java util list, right? And the last thing is, as I said, there are a lot of methods on the Javaslang list, such as size, distinct, average, a lot of them. But I want to show you this one. I create the new list. I call the distinct method. Now, so all of these 4, I'm going to only keep one of them, right? So 1, 2, 3, 4. But here the size of the first list is 6, right? 6 elements. If I append a new value, and I save this on list 2, the size of this new list is 7, because I'm append a new value. But, and this is really important, the size of the original list will be 6. This test is green, right? Because here, we are not mutating that list. We are creating a list. And this is the key, right? Perfect. I'm on time. 6. Well, yeah, pattern matching. Let's talk a little bit about pattern matching. Pattern matching is one of the things that it's available on other languages, such as Scala. I think that the Groovissimo is not here. I can say Scala. But it's not in Java, right? So Javaslang provides us this a pattern matching approach, but we need to understand that we have some limitations because of the Java language. So it's not as the same as Scala. So it's pretty much the same. So the developers of Javaslang have tried to create a similar API from Scala, but you know it's Java. It needs to be. You need to compile Java code, right? So why or when can you use pattern matching? Let me do this. So no, yeah. What's wrong with this ugly code? Yeah, if else, else if, it's ugly. We shouldn't write this code. So the first approach to try to solve this, a lot of nested if else, it's just to use a switch and a case. But it's pretty much the same, so we are not fixing everything, right? So with Javaslang pattern matching, we can do something like this. Match the value of something. And here we have a lot of options, and I mean a lot. The first case is this one, case, and just a value. So 0, 1, 2, 3. Here I don't know, so I will return unknown. So this is my test, right? I'm going to execute this method with all these values from 0 to 4. And let's go back here. No, sorry. This one. Oh, this one. So 0, 1, 2, 3, and with the 4, I'm going with this unknown. We can also use here a predicate. So we can define here a predicate, which is a function interface that will evaluate a condition and will return true or false. So in this case, if the number is greater than 2, I'm going to print greater than 2. So I can run the test again. And now, for the 3 will be here, but for the 4, it will be matched with this predicate. This one will never be executed. Okay? And the thing is that I was working last week at Campus Google, and I was there with my friend Mario, which is there. And I was showing him this code because he has been using Javaslang for a lot of time, and I want some feedback. And he said, okay, you know that with Groovy case or with Groovy switch, we have a lot of options, and most of the Ruby developers don't know about it. And I was one of them. So we can write something like this. This is Groovy code, right? So we can put this code in this way, but we can try to convert to just reformat the code to this approach. So we can do something like this. Case 0, return 0. Case 1, return 1, right? It's pretty much the same. But it's even better, right? I'm going to show you now an example, but another thing that I want to show you about Javaslang pattern matching is that we have a lot of here. This is a Javaslang class, these predicates, and we can use all of these predicate. Is in, is not null, none of, any. There are a lot of them, right? And here you can use try, you can use an option. As I said, there are a lot of different possibilities. So what Mario did, just the next day, he wrote a blog post. So this code is from his blog post. I'm going to keep it here, the URL. You should check that post because it's great. And what Mario did was showing me how to do this functional, this pattern matching, but using Groovy. So imagine that we have this user, and we can do something like this. We can match, right? In the case, we can match with a user with this name and this age. And we'll return Carl. And if it's the other one, we will return John, because we are just returning a string. And by default, we'll return a body, right? And this match this user. But we can do it even better. And this is amazing. You need to really think about it, because the first time I saw this code, I said, okay, this is not Groovy. But actually, it's Groovy. So let me try to explain this. We want to match a user, and we want to match a user in which the name ends in R, and the age is greater than 25. Here, we are going to match with this name, and with the age less than 23. Here, we are going to match to any user, but with this age, and if not, we are going to return a body, right? And the magic is here, because we always forget about closures. Closures are amazing, and it's complicated sometimes to think about this. So what this ends with? Well, it will return a string, and it will return a closure of a Boolean. And here we ask, how do I know if this string ends with something? With this one, pretty simple. How do I know if an integer is greater than whatever? Pues, number greater than whatever. And then, this any. Well, is this any? It will be true. Perfect. And here, I receive two closures. The ends with, because we are wrapping, we are returning a closure of Boolean. So I just return two closures, and I evaluate the closures. So if you don't see this code here, and if you only see this, it's something like, wow, I didn't know that I can do that. For me, when Mario told me, I said, I didn't know that I can, and I've been using Groovy for 7 years. It was totally amazing. So Javaslang pattern matching is awesome, but please keep in mind that Groovy is so awesome that you can do something like this, right? And again, I recommend you to read his blog post. He's explaining everything else. And now my last example. Yeah. This is a nice feature about Javaslang. Sometimes you want to validate some user data or whatever. So imagine that I want to create a new user. So I need a name and an age. But I don't want to create users with invalid data, right? So for example, let's go here. I want to create a user, and the age needs to be greater than 0, right? So in this case, with this Javaslang validation, we are returning, remember this option with a sum or a none, try with a success of a failure. Here, with a validation, we have a valid or invalid, right? So here, we grab our code in a validation. The first parameter, it's the type of the value that we are going to return if the validation fails. I'm going to return these error messages, so it is a string. And the second value, it's the value that I'm going to return if the validation pass, which is in this case is the age, because I want to create the user. So if age is less than 0, I'm going to return an invalid value with that message, and if not, a valid with the age. With the name, it's the same. I'm basically allowing only these characters. And once I have all my validation methods, I can do something like this. Validation.combine, and I put here all the validation, all the methods that will return this validation. And all of them will be evaluated. So if you have here 10 parameters and the 10 and all of them are grown, you are going to have 10 error messages. So this execution won't shortcut when you have the first failure, right? It will execute all of them. And then, if all of them are true, and are valid, I'm going to apply this function. So I will return, for the first one, I get the name, because I'm returning the name. For the second one, so this is the second one. I'm returning the age, because it's valid. And then I'm just creating the user, and now I know that this user is valid. So if I go back to the test and run it, it's green, and you can see here what I'm doing. I pass a string and an age. So this validator is an instance of valid, because all validation has been true. The toString representation is valid, and the toString of that class. Remember that here I'm using @canonical, so by default I have a toString implementation for free with this Groovy annotation, which is the name of the package, the class, and the parameters. I need to get the value, so remember consistent API. Once I get the value, in this case my user, well, of course, it's an instance of the user class, and the name and the age are the values that I expect. And if I try to create a new user with grown characters or with a grown age, I can check something like this. Now this is an instance of invalid. We have this error method or property which has this size, so there are two validation errors. The first one is the age, and the second one is the age. Sorry, the name and the age. These two methods or these two errors are those errors that I'm returning here when the validation fails, right? Perfect. So basically that was all. So let me just finish with this. These are the main resources. So javaslang.io, the web page. The second one is the GitHub project, and the last one is the documentation. The documentation is really good, and also they publish a lot of blog posts explaining a lot of things. If you want to try Javaslang, it's pretty simple to introduce in a Groovy project. In my last project, we use it, and we use mostly for the try block. So I think we don't use any of those, but the try, it's really helpful. You can remove a lot of boilerplate code, because you don't need to worry if, imagine that you have a try of something and you get map, or flat map, you concatenate 5 calls. You don't need to worry about put all those method calls in different try catch. It's under the hood, and it will be better, your code will be more readable, right? So that was all. Thank you very much. This is my contact information. I'm going to push the code to GitHub, and well, these 3 slides. And in that URL and that QR code, if you have something like 30 seconds, it's an anonymous Google form to send me some feedback about the talk. only for questions, anonymous, so you can say whatever you want. If you like it, please let me know. If you think it was shit, let me know, because it's anonymous, right? And we have, I think, time for at least one question. Hi. No, you need to use Java 8 because it's built on top of all Java 8 functional interfaces, the default method on interfaces, all that stuff. No, you need to use Java 8, sorry. But you know that Java 7 has been deprecated for... Okay. Next question. I had an example about that. Sorry. So it compared the values in the same order that you have defined. So in my example, you have these two coordinates. If the first are the same, it will compare the second one. But if those are not the same, one of those will be, if this is lower, it will be, so this tuple will be less than the other one. So only compare the other values if they need to. Alberto. You cannot add an element without an append. So this is the method. So in Java we have add. In Javaslang it's append. So it's the name. I don't know why they have chosen append instead of add, but that's the method. Well, you have a prepend, which is adding on the very beginning, but it's the same. You need to use any of those methods to add a value to the collection. Well, I think that's all. I don't know. I don't want to take more time. I'm going to be here, so we can talk. If you have more questions, we can talk. And remember, today we have a party, so we can talk with a beer, which is always better. Thank you very much.